Hi there. I'd like to give you an overview of the Milwaukee Makerspace Access Control system that I am currently working on. The idea behind this system is to issue our members ID codes instead of physical keys to gain access to our space, should we ever acquire a space. Anyway, the hope is that we can use these IDs to in lieu of physical keys that might be lost or stolen, and require us to actually recore all the physical locks to prevent unauthorized entries. It's very easy to simply delete a key code from a database rather than recore the doors. So what you're looking at here is what I call the exterior unit. The circuit will sit on the outside of the access control door, and will be an enclosure, obviously. It will collect the ID codes from the users and check it against the see that it gets checked against the database. It collects the IDs via either this 12-digit keypad or this RFID reader that we bought from SparkFun Electronics. It also has a 2x16 character LCD screen to give the user some feedback. You notice it says "Welcome to Bucketworks." The reason for that is that Milwaukee Makerspace doesn't actually have a space right now, but Bucketworks has recently acquired theirs, and they're in need of an access control system for just exactly the same reason. So we thought we'd build them one and get it going there first. Getting back to the exterior unit PCB board, I'd like to take a walk around the circuit here. Over here you have a switching power supply. At Bucketworks it's a 12-volt system, so 7805's got a little too hot for my comfort, so I made this little guy off of this switching chip. There's a lot more capacitors here than really need to be. I just didn't quite have the exact values handy. So these four are all in parallel, filtering the output. These three are in parallel, filtering the input, and then that's the inductor right there. Over here we have an ATmega 328 that is running the Arduino firmware with a sketch that I wrote for it. It's running off of a 8 megahertz crystal. We have a little buzzer to give the user audio feedback. And then finally we have an RS-232 to TTL level serial shifter chip. And that is what allows the exterior unit to communicate with the interior unit. And this particular circuit board resides on the inside of the access control door. Here we see the RS-232 level shifter that is talking to the exterior unit. Over here we have this black box is a 5-volt relay that actually is capable of running a door strike or a mag lock or what have you. This interior unit is also powered by an ATmega 328 running the Arduino firmware with a custom sketch, also 8 megahertz, the same switching power supply setup. And then we have an RS-485 level shifter. Now RS-485 and RS-232 are related, but there are some important differences. For one, RS-485 is a long-range bus. RS-232 is limited to about 50 feet, whereas RS-45 can go up to about 4,000 feet. Also, RS-232 is typically a full duplex bus, which means that you can both transmit and receive simultaneously because there are two separate data channels. RS-45, particularly when it's in a multi-drop configuration, is typically half duplex, so that means only one side or the other can talk. The advantage, though, is that there can be more than 2 transceivers on the bus. You can have up to about 30, in fact, or in this particular case, this chip advertises that it's a 1/8 load, and you can go up to 256. The trick is that since only one person can talk at a time, you need a protocol implemented on your bus that ensures that only one chip actually speaks. So all of the chips on the bus have to follow a set of rules that make sure only one guy talks. Anyway, what we have for the moment is this RS-55 just leading up to one other node that is a server interface module. So here we have an RS-45 talking to a SparkFun USB to TTL serial interface chip, all mounted on Eddie Wright's of WrightHobbies.net's fine prototyping board there. This is a cool little board. It allowed me to not make a printed circuit board for this and still have a complex setup. It mimics the electrical connection of a regular breadboard for the most part. But anyway, so this is connecting the RS-45 bus up to the USB, which leads me over to my server, which is running seismic right now, but there's the server program that's talking out over that USB bus. And what you see it doing is issuing ID checks, one after the other after other. And there's a few timeouts running around in there because my computer room happens to be fairly noisy. But this is implementing a protocol that is called a master-slave protocol. And this program here is the master. The interior units, which are the other nodes, are the slaves. In a master-slave protocol, slaves only speak when they are spoken to by the master. Slaves will never volunteer information on their own. Because of that fact, it's necessary for the master to poll the interior units continuously to determine whether or not there is an ID ready and waiting for an authorization check. And that's what you're seeing in this sort of debugging output from the unit. It's sending packet after packet after packet. So let's follow the packets back down the chain and watch it actually go. So each one of these ID checks comes out, goes down the USB cable into this guy where it gets converted to TTL serial and then right into RS-45. Comes over the RS-45 bus where it is received by the interior unit and this Arduino chip right here. Now this interior unit obviously doesn't have any of its own input peripheral, so what it does is it takes the packet and it relays it over the RS-232 link to the exterior unit. And this is where the ID check is actually compared. Or it's not actually, the check itself is not performed. It checks to see if there is one waiting. So if a user enters something on the keypad or something on the RFID scanner, it stores that in memory because it's a part of a slave system. It doesn't actually volunteer the fact that it has an ID ready and waiting. When the packet comes all the way down from the server to the interior unit to here for an ID check, at that point it responds that yes, I have an ID waiting that was entered some time ago to be checked. Now in practice the amount of time is in milliseconds, but there is a delay. So the fact that there is an ID comes back in through this RS-232 chip and into this Arduino, who in turn once again relays it back out through this RS-45 chip and into the server interface. Now the server interface gets the actual ID number, cross-references it to a database to find out which user it is and whether or not that user is authorized to enter the building or not. At that point it responds with access granted or access denied, and it sends that packet back down the RS-45 again into the Arduino. And at this point the Arduino makes a decision, this particular Arduino makes a decision whether or not to fire at this relay. If it's access granted, obviously it fires it. If not, then it doesn't. Whether or not it's granted or denied, though, it once more copies the packet over to the RS-232 side, over to the exterior unit, so that the exterior unit can display a message on its LCD screen, to give the user feedback as to the fact that his access has been granted, or possibly an explanation as to why it was denied. Perhaps the user subscription has expired, or maybe today that we're just fumigating for mice or something. So let's watch it in action. I have a little RFID card here. I'm going to swipe it. And it checked, said open sesame. I have an LED wired into this relay. You can see it's clicked here. And in about 7 seconds, the LED will go off and the welcome to Bucketworks sign will return. And similarly with the keypad, while you're entering, it prompts you to press pound at the end. I do that. There goes the LED and the open sesame, and the user is granted access. Well, that's in a nutshell. I hope you enjoyed this little overview. I will be releasing the schematics and the source code to both the server program and the 2 Arduino sketches very shortly. Thanks for watching. Bye.